This is a demonstration of the cyberspace deck and the PseudoScientific visualizer running under the news window system. We're going to use them to view a network of Postscript data structures that represent the structure of the ARPANET as of 1985. Now, this is one view of the structure, and what we use to model it in Postscript are Postscript dictionaries. Now, this is a dictionary here, and I can click on it to open it up and look at what it contains. And what it contains are, what it represents is an imp, one node on the ARPANET, and it has its neighbors as keys in the dictionary. Now I can open those dictionaries up too by clicking on them, and this is a whole network, so it goes down deeper and deeper and deeper infinitely because it's a network. And this could be maybe the path that a packet would take as it went from one end of the country to the other. So these data structures, I can just open up parts of them on the screen, but I can't, using this view, display large amounts of it at once, or I'll run out of screen space. And now that's what the PseudoScientific visualizer is for. What we'll do is open up a PseudoScientific visualizer on this top level ARPA imp. And the PseudoScientific visualizer is the object browser for the other half of your brain. It's a fisheye lens for the macroscopic examination of data. Now what we see here in the middle, this round thing, is that first dictionary, and growing off of it are the three neighbors of it in the network. Now I can click on one of its neighbors and bring that to the center. I've just increased the depth to which it will draw. It will just draw to a certain depth and then bottom out. Otherwise it would keep drawing forever. Now this stick sticking out here is the name of the node, like ARPA imp, DCEC imp. That's a string data type. Different data types are drawn differently here. Now, I can increase the depth even more, let's say to 6, and make this window a little bigger so it will redraw. And it draws a compound object as a circle, and then it recursively draws all its elements scaled smaller in an evenly spaced ring rotated around the circle. The deeper an object, the smaller it is, and it'll only draw to a certain depth that you can even change while it's drawing. So we'll decrease the depth here. So that it will finish up. This shows form, texture, density, depth, fan out, and complexity. As you can see, there are clumps of nodes. Now, the highlighting that's going on is showing me where these nodes are under the cursor, and I can press the button on the background to get an X-ray view of what is displayed and light up all of the mouse-sensitive nodes. Now, any of these nodes I can press on to bring to the top, or I can point at it and click the button, and it will tell me just what this object is. So I can annotate a few of these. It just drags out a hand and pops up the little window. So this is sort of a link back to the other half of your brain. Now, these objects are selectable data structures, and I can select them and push them onto the stack and edit and manipulate them. While it's drawing, it randomly forks off several lightweight processes to draw, so you get lots of drawing in lots of places at once. So that makes it more interesting, and then you get a different overlapping. So after the drawing is complete, it then makes everything mouse sensitive. And in news, these are actually implemented by small, round, transparent canvases. So the mouse hit detection is very, very simple. So if you can look at different data structures and they have very distinctive textures, this is a very homogeneous data structure. This network has a branching factor, 2 to 5 or so, and you can tell that by looking at it. Now, we're going to look at a very different data structure, which is an actual object in the Windows system that's not as contrived as this ARPANET map is. Now, it's a dictionary, and it has all kinds of other PostScript types embedded in it, recursively deeper and deeper. Now, what I've opened up is the root menu. It's the background menu that you get in News. I'll pop it up just to show. This is represented by this. Now, there's 8 items, and you see the strings that are the labels, and in the menu item array are the actual submenu objects. Or actually, these are dictionaries containing those submenu objects and some layout information. Now, so I'm going to view this, and you'll be able to recognize some of these structures. Now, an array is drawn as a circle with all its elements around it, and a dictionary is a circle with a dot with its keys and its element around it. Now, there are several options that we can choose while it's drawing, like whether or not to draw those lines there emanating out. That adds the complexity, and in something as dense as this, we really don't want the lines, so we can start the drawing over. Now, what you can see happening here is it's drawing the 8 submenu objects that are underneath this menu. And this is, I think this is the class dictionary that, these are the layout information dictionaries, and these are the actual submenus. There's 8 of them, and you can tell that pretty easily. As it gets around, we'll get to other data types. This is a null. This is a number. This plug is a null. The square is a number. The triangles are keys. This circle with a dot is a dictionary. This stuff looks like code here. Yes, this is the menu class because code is arrays with numbers, operators, constants in it, and other arrays. And it looks pretty distinctive. Now, the colors that it's using to draw are varying sort of randomly. The color of an object is a little different than the color of its parents, so that all of the children of an object will be close to the same color, but different. It's nice to have the children different colors so that if you have a lot of things overlapping, you can at least see the edges. And now lastly, here's drawn the array of menu items that we can see down here, stuff, user interface, repair. So these lines here are strings, and the length of the string is the length of the line. So if I want to point at this and say, what is this funny looking thing here? It will let me put a little pointing hand displaying it. Oops, looks like I got 2. Well, they're cheap. And this, for example, is a class. Looks like it's 2 for 1 day. I thought I'd fix that one. But you get the idea that different data structures have very different textures, and this gives you a high-level overall view of it without bothering you with any of the textual details. So let's X-ray this one. An interesting thing that I've implemented is Conditional Xray that will just highlight things that pass a certain test. You know, like if I want to see in the ARPANET every node that has a link to a certain other node, I can write a piece of PostScript code that tests that and put it as the conditional highlight function. Other interesting things to look at would be file directories, networks such as hypertext databases, and just if you get a new program and it uses all kinds of crazy data structures and you want to see how deep they are.